In this video, I would like to introduce you to functions and function notation. So a mathematical function is one in which for every value of x, which would be considered the independent variable, we have only one y, the dependent variable. So if you think about this one here, I'm going to look at that. That is the independent variable. Independent. And y is dependent. And hopefully that makes sense because the value of y depends on what x that I put in. Because as I change x, we get a different y. So we would say that y is a function of x. Okay? Y depends on what we put in for x. If we change x, we get a different y. So now, instead of using the value of y, there's this new thing called function notation, which looks like this. F of x. Now, not f times x. Just don't confuse that for multiplication. This is f for function of x. So instead of writing y equals x plus 4, we are going to write f of x equals x plus 4. And the nice thing about this notation is, as we change the input for x, we also will write it in here. So if I wanted to know what the value of this function is when I sub in x equals 2, I would simply write f of 2 equals, and everywhere we see x in the original function, like here, we will sub in a 2. All right, so when x is 2, f of 2 is equal to 2 plus 4, which is 6. This produces a rectangular coordinate 2, 6. Okay, so let's see what we mean as we plot some different points for this particular function. All right, so we're going to see what this function looks like once it's graphed. I'm going to substitute some values for x, and we will find out what the corresponding f of x or y value is, and we'll get some points. So we'll do this with a table of values over here on the left-hand side. So I'm choosing at random values to sub in for x. Any x value along the x-axis, which means negative infinity all the way to positive infinity. I should be able to sub in values of x, and we can always add 4 to any number, which means we get out a value for the y value or the f of x value. So let's randomly choose some. For example, let's see what happens when we sub in an x of negative 6. F of x, and I can write them over here, f of negative 6 equals negative 6 plus 4, which is negative 2. So negative 2. In fact, let's plot that on our axis here. So we've got negative 6 for the x, negative 2 for the y. Plot that point right there. Okay, well, I'll try negative 4. F of negative 4, that'll be negative 4 plus 4, which is 0. So the f of negative 4 is 0. So if I go over to negative 4 on the x and up or down 0 sits right on the x-axis right there. So let's do negative 2. Might as well keep the spacing consistent. F of negative 2 is negative 2 plus 4, which is 2. We'll plot that. So negative 2 in the x, positive 2 in the y, right there. How about 0, 2, 4, and 6. So I'm going to leave that for you. Pause the video, find the rest of the values, and plot the points. 6 might be a little too far because the graph does not account for that very well. So let's see. Even 4 might not. Oh, there you go. So try the other 2 points. Then connect those points. You should have a line, all right? Okay, coming back to this, I'm going to do f of 0, which is 0 plus 4, 4. So f of 0 is at the point 0, 4. There. And f of 2 is 2 plus 4, which is 6. Okay. So for the point 2, 6. And you can see why I retracted on doing 4 and 6, because that will take us up off of the graph. All right. Now, joining these to make a line. Let's see. We're going to just connect all of these points and even extend. There we go. That's a line. It goes in both directions forever, because even values in between these integers that I've done, like say I do 1, right? Put in a 1. 1 plus 4 is 5. And 1, 5 is another point on the line. All right. Even minus 3.5. Okay. Minus 3.5 plus 4 is 0.5. So minus 3.5 minus 1, 2, 3.5 up 0.5. It's a point on the line as well. Okay. So that's a function. For every input of x, we have one output. And function notation is really just subbing what we used to call the y value for f of x, or function of x. So function notation really does make it easier to indicate what the input value is, because it sits right here in the bracket beside the f. And sometimes it's not just a numerical value, but it could be some other expression in terms of x, or even a different variable that we want to sub in. So instead of having my equation that says y equals x plus 4, and then when x equals something, y equals. So this is kind of what it's saying to us, is all of this quote here, when x equals some number, y equals the output, right? We don't have to write all those words. We can just write f of whatever the number is, and then sub in wherever we see x, we should sub that value in. Just like in these two examples here, if x equals 6, I would write f of 6, which is 6 plus 4, which is 10. So I also mentioned that it's not always a numerical value that goes in the bracket there. It could be some other expression involving x, or even a different variable. But still, if our function of x equals x plus 4, everywhere that I see x in my original function, I now sub this new value in, okay? So notice that this becomes x plus h plus 4, okay? X plus h goes into there, plus 4. We don't need brackets. It's all being added together. So that's how that would look. All right, so here are a couple for you to practice. Find. In the first case, you're finding f of 10. In the second case, you're finding f of 4. Pause the video and give that a try. All right, so f of 10 is equal to, I must sub a 10 everywhere I see x. 2 plus 10, which is 12. In the second one, be careful, we have an x squared. F of 4 is equal to x, which is 4 now, and squared minus 5. This will be equal to 16 minus 5, which is 11. Okay, so everything that happened to x must happen to whatever the value subbed in is. Okay, now I'd like you to take a look at one more thing. Given that f of x is equal to x squared, find f of x plus h. You may refer to this over here as you are trying that, but let's work through this. So f of x plus h. Notice that x is now going to be x plus h, so I'm going to bracket it because that used to get squared. X plus h squared means x plus h times x plus h. And that is a binomial times a binomial, so we will use the FOIL idea. X times x, x times h times x, and h times h. We have like terms in the middle, so that is x squared plus 2xh plus h squared. Okay, so that explains why we must use this method for squaring the binomial. Now that you've seen that, I would like you to try this next one. Pause the video and give it a try. Okay, let's go through that now. So, bring that right there. So we have f of x plus h, 2 multiplied by x squared, the new x, okay, the new x is x plus h, and we must square it, plus x, that the new one is x plus h, subtract 4. All right, bit going on here. Think of order of operations. Brackets, we can't do them, they're not like terms, so we must square the x plus h. Okay, I did that up here, so I'm going to copy that because it's already been calculated up there, but if you forgot, you would work through it again. We're not multiplying by 2 yet. Okay. Squared plus 2xh plus h squared plus x plus h. Now, the brackets aren't doing any good there because I can remove them. There's no negatives or anything, so it's just x plus h. And subtract 4 from that. Okay. Next, we need to multiply 2 by everything inside the bracket. Distribute that 2x squared plus 4xh plus 2h squared plus x plus h minus 4. We'll know we're done when we have no like terms. Now, I don't see any like terms, so we are finished. All right, that's it for my introduction to function notation, and thank you for watching.